All right. Hey, good morning, everybody, and good day to everybody joining us online. My name is Sanjit Seshia. I'm a professor of electrical engineering, computer sciences at UC Berkeley, and I co-direct the Scenic project along with Professor Daniel Fremont at UC Santa Cruz. As this slide states, the two of us work with many people. There are many other leaders and contributors to the Scenic project, several of whom are in the room today. So this is the second annual Scenic project workshop. As many of you know, Scenic is an open source project that started in my research group now 7 years ago, or maybe more than 7 years ago now, almost 8 years ago. And it's an open source probabilistic programming system with a wide range of applications, but particularly centered on safe and trustworthy AI-based autonomy. Okay, so the goal for today's morning session is really to give everybody in the room a basic tutorial and grounding in Scenic. But we want to start with a round of introductions. So I will begin with an introduction to the Scenic project. I'll try to keep it brief, so 10 minutes or less, hopefully. And then we'll do a round of introductions to everybody in the room and everybody online. Okay, so that's the plan for the first roughly half an hour. And then after that, we'll do a bit of a logistics announcement at that point. And then after that, we'll have a break. Okay, so that's the initial plan. Okay, so let me get started with the intro to Scenic. So as we're all well aware, there's growing use and deployment of machine learning and more broadly data-driven AI in all sectors of society. And that's really where the genesis of the Scenic project was, that we were working in this area of autonomous intelligent cyber-physical systems, which we call AI CPS. And in particular, looking at safety critical applications like autonomous vehicles that interact with other vehicles on the road and with people. This is already a reality, as we're all well aware. But when we started the project back then, there was a lot of hype around autonomous vehicles, right? So if you were following the news back in 2015, there were rosy predictions that by 2020, self-driving cars would be everywhere and commonplace, and nobody would have to drive anymore. And then 2020 came and went, and reality hit it. And that the problem is much harder than originally predicted by at least the marketing folks, right? And unfortunately, we've seen over the last decade many incidents and accidents involving self-driving vehicles, and particularly some of them traced back to the use of AI components in those vehicles. So this is really where the project started. We really wanted to raise the level of trustworthiness in these kinds of systems. And so the goal of the research agenda, which we call the Verified AI agenda, is to really create a design flow, which I'll explain in a minute what I mean by that, for this area of AI-enabled or AI-based autonomy. That means both autonomous systems as well as partly autonomous systems. And what I mean by design flow is that we don't necessarily just want to create theory or publish one-off tools. We really would like to create an ecosystem of theory and techniques and tools that interoperate. That would be something like what we have today for chip design, where we have a whole industry, the electronic design automation industry, which has a whole body of work, theory, algorithms, and tools, commercial tools, and they can all work together to make sure that the final fabricated chip is what you designed. And we are still quite far off in that goal in this area of AI-based autonomy and robotics. But I think we're making progress. And the Scenic project is really motivated by that goal, that we want to create a representation that can work with many different techniques and algorithms and tools, right? And can serve as a common representation that enables many use cases. Okay, So Scenic and Verify, its counterpart, are two open source projects. So Scenic is a high-level probabilistic programming language for modeling the world in which autonomous and semi-autonomous systems operate. Verify is, think of it as the backend. You'll also learn about Verify in this workshop. It's a backend that incorporates algorithms for requirement specification, for various steps in the design process, synthesis, training, and so forth. Then verification, testing, debugging, and data generation. And so they're both open source tools. And we've had many users across many different sectors of society. And really the goal of the Scenic project, as we especially have worked on it for the past 2 years, is we want to bring together the community of people who are developing, especially open source software and data sets to address this problem of safe AI-based autonomy. Okay? All right, so I'll spend just a few minutes telling you a little bit about what is Scenic and what's Verify and some example use cases, and then we'll move to introductions. So Scenic is a probabilistic programming language, and so here's an example Scenic program. This is our canonical example of a static scenario. So it's a snapshot of the world at one point in time, and this is a scenario of a so-called badly parked car. And we'll go through this example in detail in the tutorial after the break. So I won't go through the details, but the point here is that every Scenic program is defining a distribution over possible worlds. Every variable in the Scenic program is really a random variable with an associated distribution, some of which are explicitly defined and some are implicit in the libraries that are used. When you connect Scenic to a backend renderer or simulator, and every time you run the Scenic program, it's going to sample a point in that distribution and render it. And that's what you're seeing here with the animation on this slide, where it's using the Grand Theft Auto 5 renderer to render different images of badly parked cars that are parked at a funny angle to the curb, but with randomization over all the other environment conditions like time of day and location on the map and so on. Scenic also has dynamics, and that's one of the things that really makes it powerful. So here you have the same badly parked car scenario, but now the badly parked car is pulling into the path of the ego vehicle, which is in the foreground, as the ego vehicle approaches close. And that's what is specified up here with these behaviors. So the behavior of the ego vehicle is not shown, but it's doing lane keeping and emergency braking. And the badly parked car behavior is specified up there. And again, this is an example we'll go through in detail. And what you're seeing is, as you sample configurations from this and you render them with the Carla autonomous driving simulator, each time you run it, you get a new simulation. And they look different, but they're all simulations that have the same characteristic of a badly parked car pulling into the path of the ego vehicle. Okay, so that's a quick intro to what Scenic is. So there are many use cases that we and our collaborators have explored over the years, over the last 8 years. So one of the first use cases was to just world modeling, environment modeling, and then using it for verification and testing of autonomous systems, both in simulation and the real world. And here is an example of something that we did with the American Automobile Association, where we found cases where the autonomous vehicle was not performing safely or was borderline unsafe in simulation. And then we were able to replicate some of those here on the real road, right? So that's the kind of thing that you can do with tools like Scenic. But we've also done a variety of things, exploring system performance, meaning you can try to see if there are particular cases where your machine learning models perform well and generate specialized test sets or training sets. You can try to debug known failures, like this bottom was an example of an image where the object detector neural network thought there were 3 cars where there was just one. And we were able to use Scenic to figure out exactly what it was about this particular image that was confusing the neural network. You can, of course, use Scenic to generate data, and then you can use that data to train or retrain your models. And you can also do design space exploration. So we've had projects in robotics where people have used Scenic to do early prototyping of different kinds of robot models, both the mechanical structures as well as the control algorithms. And then you can then implement them on a real piece of hardware, or in some cases for things like foldable robotics, we've had users create those, basically create plans to 3D fabricate robots and then implement them in the lab. And you can do design space exploration for using Scenic. Okay, so Verify, like I said, is the backend of Scenic. And if you just focus on the right-hand side of this slide, there's a whole bunch of use cases of Verify. The top 3 are testing and verification use cases, like things like falsification or fuzz testing or statistical model checking. Once you find errors, you can then debug them using features of Verify that involve data analysis. And then once you understand the errors, you might want to improve your AI models. And we have various kinds of synthesis and retraining approaches. We have one thing that's not shown here is we also have some recent work on runtime verification, runtime monitoring. That is also part of Verify. Okay, and both Verify and Scenic have been used across many domains. In fact, I have one slide talking about some of the domains that we've been involved with working. So of course, autonomous vehicles is a very canonical example for Scenic because that's the application domain that we started with. But Scenic has not been limited to that, and many of you know that because you're actually driving these applications. So we've also worked on avionics and aerospace systems. We've worked in the indoor robotics environment where you have robots navigating within building. We've worked in augmented and virtual reality, where you can use Scenic to model the virtual worlds that are overlaid real world, and then you can use it to both train and test the AI or the algorithms running in augmented reality, but you can also use it to train people. And I think we'll have a presentation tomorrow on this particular application. And then the thing in the middle, which maybe it played, but it stopped, is use of Scenic to train a team of soccer agents using reinforcement learning. Okay, and I think we'll have somebody talk about that as well. Okay, great. So that's all I want to say on the Scenic project itself. And now I think it's time to go through a round of introductions. So we have a whole bunch of slides that many of you contributed. So what we'll do is we'll start with those slides. And then if there's people who we don't have a slide for, we just have you stand up and introduce yourself. Okay?
Yeah.
And then we'll do the same thing for the people online. Okay, one limitation of this room is we don't have a mic that we can pass around. So I think most people in the room can hear you if you stand up, but people online may not be able to hear you. So if you can project your voice a little bit more than normal, that would be good.
Okay, so these are not in any particular order, so we will just jump around. Thanks everyone for putting these slides in. So Ethan, if you want to start us off.
So my name is Ethan. I'm a second-year master's student, and my hope to get out of this conference or this workshop is learn more about Verify. I also wanted to learn something about autonomous driving.
Thanks, Ethan. All right, Eric.
Everybody, Eric. The distribution student, with the same developers that everyone will learn about Scenic.
Alpisa.
I'm out from Japan. Joyce. And Joyce is involved in this. We know about that that's brother school. So we are not on the project to use the form of the system. We want to use it as a seed.
Thank you. And Arca.
Hi everyone, I'm Marco. I'm second year PhD at UNC. Here to learn more about autonomous driving experience.
Thanks. And Arya.
Hi everyone, my name is Arya Venkatesan. I'm a third-year undergrad student at UNC Chapel Hill, and I'm excited to meet people and just learn more about us.
Kai.
I'm Kai. I'm a PhD student at Berkeley, and I hope to learn about people's cases and see how Scenic can help.
And Kat, I think, is not coming until tomorrow, so skip her. Jonathan.
Hi guys,
can create Scenic and have a case like this in Colorado.
All right. Oh,
So my name is Joseph. I'm size disabilities LP. So we are now also verified our system and both was also somehow as my idea to see that last week.
thanks. Hereby?
Hi, I'm Ariel. I'm a physical science lecturer, Stanford. My goal is to explore evolution with environment to evaluate evolution network. So there are a lot of response for legal, but there is not much for legal. And I hope any type of approach that can be useful in a dynamic scenario, which is useful for verifying and your symbolic approaches.
Thanks. Martin?
Hello everyone, I'm Martin. I'm a student visiting from Sweden at Berkeley during the summer. And I'm hoping to learn more about how Scenic can be used in audits.
Thanks. Okay.
My name is Kay. I'm staying here. It's like you said, I decided to live in college.
Thanks. Yeah.
Hi, I'm Brianna, fifth year, almost sixth year, final year PhD student at University of Michigan. I've used Scenic before. Today I'm here for strengthen my Scenic programming skills and like contribute to the community as well as like building.
Okay. Lola?
Hi, I'm Lola. I'm a software Scenic. So I can see how others are using.
Thanks. Itisha?
And I want to talk about how we can face and complex and also how we can external exam.
And Fida
online.
might be online. Let's
Yeah.
see.
If you're online, please unmute yourself.
Yeah, actually, I see Fida is on there.
Oh, hi.
Um,
Can you see me?
can you say something, Fida?
Yeah. So my name is Fida Kundakar
The
Safa.
sound's
So
not coming through. Let me see.
Okay, can you try again? Can you try talking again?
hello, can you hear me?
Go ahead.
Is it better? Clear?
Yeah, we.
Oh, yeah. So my name is Fida Kundakar Safa, and I'm a thesis student from Macquarie University, Sydney. And my thesis is about like autonomous vehicle, and I'm trying to generate like test cases for my thesis using Scenic language. So that's why I'm here to like trying to make it work it out with the Scenic. And yeah, I put it wrong in the slide. I was supposed to put in the varsity name. I put FIDA. I don't know why. In the middle side.
Great, thank you.
Yeah, and thanks for joining all the way from Australia
Yeah.
at this time.
Yeah.
We have another slide.
All right. Next, we have Victoria.
Yeah, I'm working on like tools for better student systems testing, so things that incorporate Scenic into that.
Okay, I think that is all the slides we got. So I think there might be a few people we didn't get slides from, or if you did send it to me and I missed it, apologies. So is there anybody we didn't introduce? Lawrence, okay.
Hi, my name is Lawrence. I'm a professor Berkeley and student in the economics of autonomous racing.
Oh, yeah, Luis, go ahead.
I'm a student in systems. I'm interested in thinking on verified and security applications.
Thanks, Luis.
Then one more.
And we're hoping to learn more also, but we're also looking for.
What's your name again?
Salim.
I think I can say
Anyone
the
else?
rooms. And so we should.
Okay,
just go
yeah. So I see there are a number of people online. So let me switch microphones here to the other machine and put the sound on there, and then. Okay. So maybe Jean, do you want to introduce yourself?
Yes, hello, good morning. So I'm Jean. I'm a professor emeritus at UC Berkeley, and I'm generally interested in methodology for verification and simulation.
Thanks. And Kamalika?
Hello. Sorry, my camera isn't really working at the time.
No worries.
Hi, I'm Kamalika. And I'm interested in just learning more about Scenic so I could eventually use it for like research labs. And I'm affiliated with John R. Lewis from UC Santa Cruz.
Thank you. Kyle?
Hi, I'm Kyle. I'm an incoming senior at UC Santa Cruz, and I'm looking to explore how Scenic can be applied to autonomous systems in agriculture.
Thanks. Nathaniel?
Hi, can you hear me?
Yeah.
Hi, I'm Nathaniel, a third-year computer engineering student at UCSC, and I'm currently using Scenic in my research labs, especially at AEF. And I'm working with the Carla simulator to try to recreate scenarios. Yeah.
Thanks. Srivatsan?
Hi, can you hear me?
Yeah.
All right. Hi, Srivatsan, I go by Vatsan. I'm Chief Scientist at Lockheed Martin, ATL. Previously, I was an engineering fellow from Honeywell Aerospace, and I largely work on AI and autonomy assurance. Looking to learn more about the Scenic capabilities. I am, used it in the past and looking to hear what the new additions are and how people are using them. Thank you.
Thanks. And Vaishali?
Hi, my name is Vaishali and I'm a senior airspace integration engineer at Supernal, a member of the flight tech team. I'm here to learn more about the Scenic API, how it interfaces with other simulators, and specifically about synthetic data generation in the aviation domain. Thank you.
Great. Thank you all very much. I think we got everybody.
I think so.
Okay. So then let's switch the microphones back.
And if you want to bring up the schedule, please.
Yes. So a couple of logistical notes here. So this is the main Scenic website. Hopefully you've all found this. It's scenic-lang.org. If you just search for Scenic, it will come up. And for today's event, if you haven't seen it already, we have a page for the workshop. If you go down to events here, workshop 25, here's the page which I emailed out to everybody earlier. And a few things to note on this page. If we go down to logistics, we've got the Zoom links if you need to, tomorrow, some of you will be giving talks and things. If you need to share your screen or something like that, that you can use that. You all found the room over here, so that's good. The restroom is in a corner right over here if you need to use that. We'll be having the coffee breaks and the reception tonight also in this room. At a few times in the schedule, we will have a parallel session going. So in particular, right after this, for new users of Scenic, we're going to have an introductory tutorial. But if you already know a lot about Scenic and would like to go to our office hours, where you can talk with Scenic experts and get help on your own projects, ask more advanced questions, etc., that will be in our breakout room, which is about a 3-minute walk in that direction. Eric and Kai will go over there after this and can point you in the right direction. The dining hall for, some of you may have already been in there for breakfast, but those of you who haven't, it's right next door over here. So we'll be walking over there for lunch. If you are not staying in the dorms and you drove here, I have a card which will let you, which you have to scan basically for lunch. So we'll all go over to lunch together and then I'll scan you in there. If you're staying in the dorm, you should have your card that you have on your lanyard, and that will work for the meals.
I think one more logistical thing for people in the room here, that there are power strips that have been run, and in some places there's these poles that stick up.
Yeah.
So this is going to be a hands-on workshop. You will need to have your laptops out, especially starting the next session. And so you can plug in and connect to Wi-Fi. And maybe a word on Wi-Fi?
Yes, so we have EduRoam if you have that set up. If you do not have EduRoam set up, there's a guest network called UCSC-guest, which I'm not actually seeing right now on my computer, but oh yeah, there it is. Yeah, UCSC-guest. There's no password or anything when you log in, or when you connect to it, a thing will pop up asking you to agree to something, I think, and then you should just be in. Let us know if you have issues.
And then for our online participants, you can stay on the Zoom link, and there are 2 Zoom links. I think it is information was emailed out, but it's also here on the logistics page.
Yes, and so the 2 links, there's the main link, which is the one we're in now, of course. And then in a moment, when we start the parallel sessions, we will have the breakout room in a separate link if you would like to be in the office hours. And then later, like tomorrow, when we're having the autonomous driving and robotics working groups, we'll have autonomous driving in the main room, robotics in the other room. This is all in the schedule. So for example, here, right now we're in the introductions here. Right after this, we'll start the parallel sessions, and we've got in the main room the tutorial, but in the breakout room, the office hour. Okay, so we'll have the alternate Zoom link for that and the other classroom. Also, for this tutorial we'll use in just a second, we'll have a Colab notebook, which we'll talk about in a moment. But that's basically the plan. You can see the schedule for the whole workshop laid out on the page here. I don't think we're anticipating any changes from what's there right now. Are
there any questions?
Yeah, any questions at this point?
Oh, all right, great. Okay, so I guess we can move on to the parallel sessions.